Hello. Hi, Victory. Can you hear me? Hello. Hi, Victory. Can you hear me? Hello. Hi, Victory. Can you hear me? Hello. I think the your microphone is connected. Can you hear me? Hello. Now you're muted. Hi. Um, is my voice all right? Hello. Uh, all right. Yes. Okay. Now I can hear something.
Yeah,
Okay.
something is up with my microphone. I'm not really sure what's going on.
Okay. All right. But now it's fine. Now it's fine now. Okay.
Okay, let me try
All right.
something as well.
Okay.
How about now?
Okay. Yes, it's good. It's good.
It's
Yeah.
good. Okay,
Yeah.
good.
All right.
All right. Let's
All
just
right.
see.
So how have you been this past week?
I've been good. I've been all
All
right.
right. Good. Is
So just
Herman going to be joining us or probably not?
I don't know. I don't think
Okay.
so. It's
Okay.
probably
All
on
right.
holiday.
So then we can start, I think.
Um,
All right.
yeah.
Okay.
So in terms
So
of
yeah, you like to update?
sorry, yes. I've been basically thinking about the coding system or the basically how I'm just trying to find this Google Drive document, but the idea was how do I what's the best approach to developing the software, for example, the forwarding. And what I did now was I went to the PubSub JavaScript one that exists currently,
Okay.
where it came to I'm trying to remember the name of that Java. That's basically that channel-based library we're trying to extend the ADs, the one Professor Harman is working on.
Okay.
Or
MQTT.
the MQTTS implementation.
Okay.
So just by looking at it, I actually got quite a few ideas in terms of
Nice.
just the requests that can be made, for example. I don't think I factored some of those things into consideration. For example, like basic handshake, like what a handshake. Sorry, I don't know if you're saying something.
No. Go ahead. Go ahead.
Um, okay. So there were all these like commands that basically the network, for example, the network layer makes for you, such that when you're making a request, you're not necessarily sending everything at the same time. And I remember seeing something like that in your thesis as well, the master's thesis, where there was a sense of, okay, before you actually send a request, you want to establish a connection, for example. And at all these layers, there's a data structure for each component. And so now I'm thinking to actually go into that detail as to, especially from the development part, because I think that also makes things significantly easier. Where I'm trying to, where I wrote this thing now. So there's like the request, I've sort of played around with the request type, basically having like a universal, I can share that with you quickly. It's a basic thing though. I don't know if you can see my screen.
Okay. Yes.
Okay, change that. But basically, you have a basic request, and for every request that's sent, or every either publish or subscribe, there has to be a timestamp of some sort. There has to be a unique ID, right? There has to be the
Right.
address, which is IP port. It has to have the area of interest, and then the type of request, whether it's a publish or a subscribe or non-subscribe. And the idea is based off this, whatever request is made, the node now has to break it down. What do I mean? Okay, I'm a node. I'm sending a request to my matcher. The matcher now is just basically going to use, okay, I want to make a handshake, connection to my nearest matcher, for example. I'm not going to send all of this, or as a matcher, I wouldn't necessarily send all of this. I'm just going to use the address, for example, component. Basically, there has to be some layer that sort of breaks all of these components down in each node or in each matcher. And the idea now is what are those components exactly? And I can show you AEDS API. And that's where I sort of found inspiration from some of these, probably subscribe, unsubscribe, there's the closing, for example.
Okay.
This is not what I'm looking for. It's the other one. Basically, I think this is the server.
Oh, this is the MQTT interface.
The MQTT, yes. This is for the server. And then the idea is there's all this like stuff, for example, there's a ping, which is almost like you're not necessarily sending quite a lot of stuff. You're just basically pinging, for lack of a better word.
Right. This is to check for aliveness.
But yes, exactly. So stuff like that. I mean, you don't want to send the full request. You just want. So the idea is, okay, what if we use this as a reference? Maybe not everything, but in terms of the process flow, and which is where I think I'm going to take your method now, where I'm going to have like a bullet format, a bullet point approach,
Okay.
where I'm saying step one, literally ping the servers around you. And again, this from a development perspective, and I have to go back to the network layer to actually understand what exactly it can do and what it can do. To understand what detail, for example, if there's a ping, for instance. So there's all this stuff that happens before the actual subscribe or the actual unsubscribe.
Okay.
Yeah, I know. Sorry, I know I said a lot of stuff, but it's something that is sort of in my head-ish. But from a development perspective, like I said, there's a sense of now, and I think I'm going to go into it like more into detail now. I actually realized that it's not as difficult as it looks. It's just time. It's just something you need to sit down with and just power through like 6-7 days in a row.
Okay.
Like a
well, it's
half
probably not. Yeah, I mean, it's good to take intensive sessions, but if you are concentrated and productive enough, probably won't take that long. Okay. Actually, since you're mentioning this, I am actually thinking about what's the most productive thing that we can do. Okay. And I am actually thinking that maybe we can just start now to just sort of lay down what are the basic procedures and go through them. You know, like I mean, I don't know if you have anything else to discuss or to update.
No. That's the other update was I sort of got what's his name, Raghav. We sort of had our first like check-in session, and we sort of agreed, and I think I told you.
Oh no, I haven't got updated on this yet. Yep.
Oh, sorry. Basically, I've created an issue, for example.
Okay.
And basically assigned it to Raghav. So I've added him as a collaborator on the project. And the idea is every week we're going to discuss what's next. This is just step one. And the idea is he's a very he's good at the front end stuff. So the goal was, you just focus on making it look clean, so that at least you can get a sense of what the code base is, and you can get to work with the code base and also play around with different designs, minimalist designs. Yeah. So that's this. We're starting with the sign up, sign in, where there's login, social, logo, which you technically have. Don't get me wrong. It's just what we discussed was just using cleaner interface, such that a user is excited to use the product and not necessarily, So once this is sorted, which is what we'll talk about on Sunday again, then the next step will now be to actually integrate it with the existing, publish, subscribe, MQTT interface. Yeah,
that's great.
In terms of server, we've not really decided yet if we should just stay with Firebase or Google servers, because I remember we paid for that, or at least Professor Amadi said paid. But the idea is temporarily we can just use that as servers. I don't know which server yet, basically, I guess it's down to where we can deploy the MQTT thing.
Agreed.
Yeah, but
yes, I think the steps here is to basically streamline the user experience first. You know, like you do have to have a account creation process, right?
yes,
And then you can, like what we already have, once you log in, you can see a list of your friends, right? Or this is something that might need to be added, like search for users online, right?
yes,
and then once you click on
exactly.
someone, you know, you can have a one-to-one conversation, and then you can exit that conversation anytime, go back to the list, and then, you know, pick someone else to chat again, right?
Yeah.
I think once we have that kind of workflow, I mean, that would be the first step, right? And the next would be to replace the backend using MQTT, right, instead of Firebase, right? And the purpose of this is so we can start to adopt a sort of MQTT kind of backend interface to support a chat app, right? And, and the third step would be to sort of enhance or replace that MQTT server with a modified version that we built that potentially can be more scalable and multi-mature and all that, right? So I think this is a three-step process. And to get the success that we might aim for in terms of user acquisition, all that, I think that is something that, you know, if we can just complete even the first two stages, it's already a usable product, you know. In the sense that, you know, you can, because what we are asking or telling people is that we will do this in a sort of a decentralized fashion so that the servers that are providing the chat messaging actually are distributed. Okay. And I think with a MQTT implementation, that is something we can actually show, you know, because even with current PubSub mechanism, I think there are probably multi-server MQTT solutions or deployment configuration. Okay, right? Does that make sense? So I think this is one track. Okay, this is, we might call it the usability track, okay, of things, which is more towards user adoption, right? Getting people to actually use something like this. And then there is the research track, okay, which is essentially trying to figure out how we can put spatial PubSub support, you know, integrate that to MQTT, and then scale that, right? Scale that using partitioning, right?
Sorry, do you mind repeating the last part? I was just being.
I was saying that so that we can scale it. Basically, the research track is more about how can we scale up. Well, the first is how do we add spatial PubSub to the MQTT, right, interface. And then how to scale that, right, in terms of the number of users and, you know, the area to publish and subscribe. Okay. So yeah. All right. So yeah, and I guess any questions, feedback? You were saying?
Yeah, no, I mean, it's something I've been thinking of as well in terms of just the how do you put it now, the whole testing part, because it's I've been thinking, I mean, when you just using the simple laws of, you know, there's a problem, there's a proposed solution, there's still the question around why we think it would work. Right. And in theory, and let me not say in theory, based on what I've seen from past research, which was done with the MMVs, the idea was spatial PubSub allows for better scalability, better latency, and please correct me if I'm wrong.
Okay.
Right. but in terms of comparing it with channel-based PubSub, I don't think that's been done yet.
Oh, right. That is true, because in a sense, it's kind of comparing two different things, right? I mean, some might call comparing apple with oranges, right? Because after all, they are different functionalities, okay, in terms of the functions. However, from a messaging system point of view, they are also quite similar, right?
Okay.
Because you know, if you look at just from the PubSub paradigm, they are literally the same, except for the matching criteria, right?
Okay.
So
Yeah.
so from that perspective, they should be and can be comparable. Okay. And it's good you point out that nobody has done this yet. So that's, again, if we can sort of make the comparison and let people understand the similarity and differences. I think that's also a form of contribution.
Okay.
So that?
I mean, so the big question, for example, so when I try to like explain the concept to people, and they sort of get it, don't get me wrong, they're like, it's like an exciting stuff. But the question where I get stuck, or there's the question around why.
Okay,
yes, right. we have our why, right, which is scalability and robustness. And so it goes back to the question of what are we comparing it to?
Okay, right. So, well, I would say that having a spatial PubSub interface, it eases the development effort. If you were to do some spatial application, you know, or spatial database management, spatial data set. Okay, I would say that it actually ease, you know, make it easier to sort of develop or to conceptualize or to, you know, just build something. Because, you know, just think about this, right? If you were to do an LBS, location-based service, something like Uber, something like Google Map, and all you have is just channel-based PubSub, right? All you have just point-to-point communication. How are you going to do this? You see? You run into a lot of complicated issues, right? You have to address, well, for one example, partitioning. How are you going to do the partitioning, right? And for another, you have to do a sort of a partitioning to topic or channel mapping, right? Usually you have to devise some kind of roles for this kind of mapping. And then you have to worry about what is the right size for the partition, right? Are you going to make it big? Are you going to make it small? If there's flow imbalance, how do you address those issues, right? So you see, I mean, this is exactly what the virtual environment or the gaming virtual world researchers ran into. Because at their disposal was literally just point-to-point communication, and then maybe something like a PubSub system. And indeed and in fact, there has been work that is trying to address the spatial needs with a channel-based PubSub approach, right? I'm sure you have seen works like that, right? Like the most widely cited SIMMOD paper. That was the 2004 Infocom paper. I think that's the most widely cited peer-to-peer, virtual world paper right now. That's literally what they do, right? What they did was to partition into grids, assign them to channels, and then do PubSub.
Do you mind sending that paper again? I know you sent it once.
SIMMOD. I mean, I think that's the paper. Some peer-to-peer support for massively multiplayer, something like that. I mean, that's the most widely cited paper. Okay, because it was early and also published at a major venue, Infocom. And yeah, I believe Vang is the second highly cited paper in the area. So I mean, I mean, because we were doing that pretty early. Okay, that was in the 2003, 2004 space.
Okay.
So I guess is that clear? More clear now? I mean, did
Yeah,
that
yeah,
answer
no,
your
it is.
question?
Yeah, I'm seeing what you mean now. So we're not necessarily comparing our results or our outputs based on, you know, PubSub, for example, or channel-based PubSub. It's just that our solution happens to be draw inspiration from Publish Subscribe.
Right.
But
You
it's not
can say that.
necessarily like a replacement
Right.
or
It's
a
not a
like for like
replacement.
replacement. It's
No,
not a
not at all.
replacement. No.
Not at
Okay.
all. Not at all. No,
Okay.
it's not the paper is if you just type peer-to-peer support and then peer-to-peer support and then MMOG or massively, then you can find the paper. Something like that. Oh, sorry. So peer-to-peer support for and then just massively. I think the third keyword is massively.
Okay.
Just remove MMOG or peer-to-peer support or infocom. Yeah. Okay.
I think I saw a reference in your paper now.
Right. It's in my master thesis. That was yeah.
Is
You
it
just
Fiedler or something like that?
remove MMOG. I think probably yeah. That's the
Oh,
one.
there.
Yeah,
That's the one.
That's the paper. That's the SIMA
Okay.
paper.
Oh, nice.
Yes.
Hmm.
And yep. Okay. All right. So
Nice.
yeah. So
Same
Victory.
mod. Okay.
Yeah.
Okay.
So Victory, I think what I'd like to do is to maybe we can just walk through like the first procedure.
Okay.
Okay. Just to I guess to have some idea about what does it take to create such a procedure, right? Okay. So I think we can start with which one would you like to do first?
So in theory, there's already a PubSub process that's been done, like a basic PubSub. And when I say PubSub, the channel-based system has been created. The matcher, one matcher, for example, or let me not say one. Yeah, the system has been created for just one matcher, where you have maybe 10 nodes connecting to a matcher.
Okay.
And this request has something, maybe, for each node, the assumption is it has all of this information. It has a timestamp, it has an ID, it has address, and it has its request type, right? That has been made in real time. So the big question is around forwarding procedure. All right.
You're talking about forwarding, right?
Yeah.
Okay. All right.
But then I'm not sure if I should try to create something basic from a PubSub perspective as well. Or maybe I can work with a leader with that.
You can work with that later. Okay, let's do forwarding. Okay, since I think that might be the the most that could be the more confusing one. Okay. So with forwarding, you start by I think again just a pub or sub request. Okay. So like for example, the first step could be something like sending from a client sends a request, right? It can be pub or sub, it doesn't matter actually. To the matcher, right? So you can just make the first step or the bullet, right? Yes, by the matcher from client.
Client, yes.
Right? Okay.
Yeah.
And then, right, the second step would be the matcher checks the request. Okay, well, now you have to determine if it's pub or sub. But yeah, okay, let's use pub for example. Okay.
Yeah.
Right.
Yeah.
Right. Okay. And obviously there are different ways to deal with that. But let's say okay, so you check the request tab and you handle accordingly.
Okay.
Okay, so what this means is that you handle the request. The next step you can say you handle the request locally, for example.
Yes,
Right.
and the request. So there's a sense of I want to check my basically check my local area first if there's an overlap.
Right. I mean, yes, that's correct. And if that's true, right? And then
Yeah.
you would, if it's a, for example, if it's a pub request, then you simply check if that pub request matches any of my subscriber, right? I check against my subscriber list.
It's true. Handle okay. And the request locally. If so, okay, I'm just gonna say if this is for pub.
Right.
If pub request. So handle where I'm checking for local request. If overlap is true, then I'm saying, you know what, perform standard process, pub standard process, which is you look through the list and basically
Right,
send them.
exactly. And you send it to the subscriber.
Okay. And if overlap is false, okay, sorry, else.
Well, if it's false, you do nothing, right?
Mm,
So you don't have to do
nothing.
anything. Yeah. Actually,
Oh,
the else you can remove the else because you don't do anything if else it's else,
okay.
right? Okay.
Oh, yes. Okay. So if
Okay.
overlap is false,
Right.
okay.
I mean, basically you don't
Oh,
have to
okay.
write anything. Yeah.
Yeah,
All right.
okay.
So for the next thing is that you then check if you want to forward. Okay. So you perform what may be called a forwarding check. Right.
Forwarding check. Okay.
Right. You perform a forwarding check.
To check for request.
Exactly.
Yeah.
And the forwarding check is literally, you check if the request area match any of the neighbors, the neighbors neighbor matchers region, right? Because if it doesn't match any of my neighbors, it stops at me, right? There will be no forwarding. However, if the request area overlaps with any one of my neighbors area, right? I mean, the neighbors control region or the neighboring matchers region, then I will forward.
So this is, for example, in a case where the request is a very large area that covers maybe 3 different areas, for example.
Right, 3 matches, for example.
3 matches, yeah, 3 matcher regions, right? Zones. Okay. So I'm checking, right? So for every, so there's a sort of for loop here. For every area that overlaps, where true, hold on. So in this case, I think I just have to put like a bracket there. Von request query.
Right.
Okay. So for everywhere where overlap is true, I mean, yes. For pub, do perform. Okay, no, now standard process is not the same, right?
Yes.
Because now, yeah, now we're saying establish a connection or something like that. By the way, I think this should have a standard. This is probably like a standard process.
So the okay. Yes. So for the forwarding, okay. Besides whether there's overlap, there's another check, which is whether you remember when we do the forwarding, we try to avoid redundancy, right?
Yes.
So the redundancy is being avoided by doing a check that whether I am the node that is the parent, to my neighbor if there's a line that's being formed from the origin. Okay, from the
Oh,
origin
okay. Oh, yes,
to
yes.
my neighbor. Remember?
Yes.
That
Yes,
is
yes.
a single check, actually. Okay. So, we might call this the redundancy check, right? The
Okay.
forward redundancy check. Because if that check is passed, then we can forward without worrying about redundancy, right?
Yeah.
So, I mean, you can fill in the details of the check later, but essentially it's a it's a forwarding redundancy check.
Check.
Right?
Basically to make sure that there's not requests that were repeated.
Right, exactly. Right.
Okay. That's fine. So basically there's a redundancy check, it makes sure there's no redundancy, and if
it's a forwarding. Yes, you can also say it's a forwarding check with redundancy check. Okay. I mean, I guess what I'm trying to say is it's actually two things because it's possible that it passes the redundancy check, but the subscribe or publish area doesn't really cover that neighbor. So you still have to do a sort of an overlap check.
Okay.
So maybe we can say there's an overlap check.
Overlap
right?
check.
That has to be done first, and then you would do a redundancy check.
Right? You can call it global overlap check, which is the Van query. Okay. But when I say global, for lack of a better word, but the idea is first checking your local area,
right,
or your local matcher area for overlap. You check, you perform the standard processes.
Okay, right.
And then perform also to make sure that your neighbors are not, I mean, for example, what if the subscription area covers the whole zone? Right. So you're basically checking, like, okay.
But note that you cannot really have a global check. You are still checking against your known neighbors, you see.
Oh, no, when I say sorry, just so I'm trying to think now, because when I say global, I'm thinking about the matches now. To a certain extent, well, let me say, okay, I think global does not work in a P2P context.
No. Yes,
but
you have to. I see what you're saying. You want to check if it's overlapping to a few matches, right? Like more than one.
Yes.
Globally.
Yes.
However, note that we are designing a P2P protocol, as you said. So there always assume local knowledge. You can only do things locally. You can never do something that's globally.
Yes. Yes,
okay.
Exactly.
Yeah.
So there's maybe super local, but I will have to think of.
Well, it's an overlap check. I think that's fine. That's just or neighbor overlap check, something like that. Right.
Okay.
Yes.
So we have that. So we do the check, right?
Right.
So if overlap is true, or no, for overlap true, I don't know if that's a thing. Perform forwarding check.
It's well, I mean, they're both. I mean, that is the forwarding check. If overlap is true, then you do the redundancy check.
Oh yes,
right?
Yes, yes. Okay. The redundancy check for requests to be sure that this thing will not be repeated.
And then you just forward the request.
And then you just establish connection. I'm just calling it matcher to matcher to M.
Well, the probably it's also not needed. The reason is that you should be connected to all your enclosing matchers anyway, right?
Establish.
Regardless
Yeah,
it's
yeah.
Voronoi or other partition, you can probably assume you
Oh,
are already connected to your
you're already
neighbor.
connected. Oh, okay.
Yes.
Oh,
yes,
yes. Okay. So it already knows about it. It's not
yes,
like it
yes.
has to.
It's known
So I'm
neighbors. You're just
just
passing that.
passing that. Okay.
You
Okay. So
just
there
pass
should
the
be like a
request. And also, the fun thing
site.
is it's the same request. You don't have to do any modification. You just simply pass the same request to the next matcher and that the matcher do all the checks locally. You see?
Okay. Okay.
So it's
That's
actually
cool.
not that complicated if you look at
It's
from the
not.
slide. Right?
I think I said I need to do a bit of a hackathon, and because I've done it in the past where
Okay.
I think
Okay.
I learned how to design Android apps in less
Okay.
than a month.
Okay. Okay. Nice.
All I did
All right.
was I sat down for like 3, 4, like night after night, and I
Okay.
couldn't sleep.
Okay.
I couldn't sleep if there were bugs.
All right. Okay. Right.
I don't know what happened to me. I think I got comfortable or something. And yeah.
Okay. That's nice.
But yeah,
All
no,
right.
it's not nice. I lost passion. I think. I don't know.
Okay.
It's money does that.
Okay. I
Sucks.
see. Okay.
All right.
All right.
Okay.
So Victory, I think the reason why I want to walk through this now is, this, you might think of this as something that's difficult or kind of challenging. I like to show you that it can be quite simple. Okay, like something like this. So you can see that we already have done the forwarding procedure actually.
Yeah.
And the other procedure should be same or even easier than this one.
Yeah.
Okay.
No, it's I'm seeing what I think at the moment now I'm sort of having ideas of how to test. I mean, basically how to evaluate the performance. And I think we will definitely want to compare the channel based and spatial based. Not well, then I say compare now. I think you come up with an idea as well where say we have one channel and 10 nodes, and we also have like one area and 10 nodes, and sort of send the same amount of messages.
Yes.
Just measure latency, and because chances are people from the industry will ask, why should we use this?
Right.
How does it perform compared to channel based?
Right.
But it's not a replacement, which is again, I think that's where I've confused things as well.
Right.
It's not like a like for like replacement for channel based. It's just we're drawing inspiration from.
All right. So Victoria, I think as the next step, well, you continue on the user client, okay, and for the research part, probably clarify all the other procedures, and then see how this can be implemented. Maybe by the current team, Alida, you, and Josh, right?
Yeah.
Right. I think Josh should be about ready now, so I think I'll ask him to invite him to join us next week.
All right. So that's fine. That's fine.
Yeah. All right. So yeah. So any other questions from Victory?
Now for now, I think I'm fine. I'll try to play around with the development this weekend as well, just to get some stuff started, at least from JavaScript. Okay. I've had some epiphany moments, some eureka moments in the past week or two, and I think I lost motivation somewhere.
Okay.
I mean,
start with something small, all right?
Yeah. I'll basically go back to the VS Code, try to see what the networking layer can do, try to see if I can play around with the Vaughan layer as well, just playing with nodes and adding nodes and playing with the what do you call it, the message format as well, basically to know what is what, modify stuff as well, and then build forwarding based off that.
Okay. All right. Okay. So good luck, and I guess I'll see you next Monday then. All right.
Yes.
Okay.
Yes.
All right.
Monday it is.
Yeah. All right.
Thanks so much.
Take care. Yeah. All right. Take care. Bye bye.
Yes. We'll chat soon.
Bye.